This chapter first discusses the meaning of causation from two different perspectives, non-mothetic and idiographic. Then we review the criteria for achieving causally valid explanations. During this review, we gave special attention to several key distinctions in research design that are related to our ability to come to causal conclusions. The use of an experimental or non-experimental design, and reliance on a cross-sectional or longitudinal design. By the end of the chapter, you should have a good grasp of the meanings of causation and be able to ask the right questions to determine whether causal inferences are likely to be valid. You may also have a better answer about the causes of crime and violence. All right. So identifying causes, figuring out why things happen, this is the goal of most social science research. A cause is an explanation for some characteristic, attitude, or belief, behaviors of groups, individuals, or other entities, such as family organizations or cities, or for events, is what we consider to be causal explanations. Quantitative or non-mothetic causal explanation is a type of causal explanation involving the belief, the variation in an independent variable, that it will be followed by variation in the dependent variable when all other things are equal. An example of non-mothetic causal effect is individuals that are arrested for domestic assault tend to commit fewer subsequent assaults than do similar individuals who are accused in the same circumstances but not arrested. Ceteris paribus is the belief that the variation in the independent variable will be followed by variation in the dependent variable when all other things are equal, or when all other potentially influential conditions and factors are also taken into consideration. This is the Latin term which means all other things being equal. For instance, researchers might claim that the likelihood of committing violent crimes is higher for individuals who were abused as children than it would be if these same individuals had not been abused as children. Or researchers might claim that the likelihood of committing violent crimes is higher for individuals exposed to media violence than it would be if these same individuals had not been exposed to media violence. The situation as it would have been in the absence of variation in the independent variable is termed to be counterfactual. Counterfactual is the outcome that would have occurred if the subjects who were exposed to treatment actually were not exposed, but otherwise had an identical experiences to those that they underwent during the experiment. Of course, the fundamental difficulty with this perspective is that we never ever really know what would have happened at the same time to the same group if the independent variable had not varied, because it did. We don't have a way to really test that. Quantitative researchers seek to test non-mothetic causal explanations with either experimental or non-experimental designs. However, the way in which experimental and non-experimental designs attempt to identify cause differs. This differs quite a bit. It's very hard to meet some of the criteria for achieving valid, non-mothetic causal explanations using a non-experimental design. This qualitative idiographic or causal explanation is the other meaning of the term cause, which is the one that we have in mind very often in everyday speech. Idiographic causal explanation is an explanation that identifies the concrete, individual sequence of events, thoughts or actions that resulted in a particular outcome for a particular individual or that led to a particular event. It may be termed an individualist or historic explanation. A causal effect from an idiographic perspective includes statements of initial conditions and then relates a series of events at different times that led to the outcome or causal effect. The causal effect or idiographic perspective is when a series of concrete events, thoughts, or actions result in a particular event or individual outcome. Ideographic explanations are also typically very concerned with context, with understanding the particular outcome as part of a larger set of interrelated circumstances. Ideographic explanations can be determined holistic. Context is a focus of causal explanation. A particular outcome is understood as part of a larger set of interrelated circumstances. An ideographic explanation pays close attention to time, order, and causal mechanisms. Ideographic explanation is deterministic, focusing on what caused a particular event to occur or what caused a particular case to change. As in non-mothetic explanations, ideographic causal explanations can involve counterfactuals by trying to identify what would have happened if a different circumstance had occurred. But unlike in non-mothetic explanations, in ideographic explanations, the notion of a probabilistic relationship, an average effect, does not really apply. A deterministic cause has an effect in the case under consideration. An example of an ideographic causal effect is an individual is neglected by his parents. He comes to distrust others, has trouble maintaining friendships, has trouble in school, and eventually gets addicted to heroin. To support his habit, he starts selling drugs and is ultimately arrested and convicted for drug trafficking. Association is a necessary criterion for establishing a causal effect. We can have a greater confidence in a study that observed a number of students, some of who watched a violent video, and some who did not. That way, a conclusion can be based on finding an association between the independent variable, which is the viewing of a violent videotape, and then the dependent variable, which in this case is the likelihood of aggressive behavior. The criterion for establishing a causal relationship between two variables is a variation in one variable is related to variation in another variable as a condition to determine causality. So this is what we consider to be an association. Although association is a necessary criterion for establishing a causal effect, it's not sufficient on its own. We must also ensure that the variation in the independent variable came before a variation in the dependent variable. The cause must come before the presumed effect. This is the criterion of time order. Time order establishes a causal relationship between two variables. The variation in the independent variable must come before variation in the dependent variable. So take the example above about students viewing a violent video. This experiment satisfied this criterion because he controlled the variation in the independent variable. All students saw the movie excerpts, which varied in violent content, before their level of aggression was measured. So to conclude causation was involved, we must see that cases were exposed to variation in the independent variable before variation in the dependent variable. Non-spuriousness is another essential criterion for establishing the existence of a causal effect of an independent variable on a dependent variable. In some respects, it's the most important criterion. Non-spuriousness is a relationship that exists between two variables that is not due to the variation in a third variable. We have to keep in mind that an association between two variables might be caused by something other than effect of the presumed independent variable on the dependent variable. Spurious relationship is a relationship between two variables that's due to a variation in the third variable. Example, if we measure children's if we examine children's shoe sizes and their academic knowledge, we will find a positive association. However, the association results from the fact that older children have larger feet as well as more academic knowledge. Shoe size does not cause knowledge or vice versa. In this case, Age is the extraneous variable. Sorry about the whiny dog in the background on this slide. Mechanisms. While many people believe that causal or internal validity is achieved by meeting the criteria of association, time order, and non-spuriousness, others, however, believe that the two additional criteria should also be considered: mechanism and context. Confidence in a conclusion that two variables have a causal connection will be strengthened if a mechanism, some discernible means of creating a connection, can be identified. A mechanism is a discernible process that creates a causal connection between two variables. This seeks to answer the question, what process or mechanism actually is responsible for the relationship between the independent and dependent variables? Note that some explanations rely more on speculation than on actual empirical evidence from this particular experiment. Nonetheless, by proposing a reasonable causal mechanism that connects the variation in the independent and dependent variables, we can strengthen the argument for the causal validity of our conclusion. Context in the social world. It's virtually impossible to claim that one and only one independent variable is responsible for causing or affecting a dependent variable. A cause is really only one of a set of interrelated factors required for the effect. When relationships among variables differ across geographic units like counties or other social settings, researchers say that there's a contextual effect. Contextual effects are relationships between variables that vary between geographic units or other contexts. Identification of context in which a causal relationship occurs can help us understand that relationship. We can always ask what else might be important. In which country was the study conducted? What are the ages of the study participants? We need to carefully review the results of prior research and the implications of relevant theory to determine what contextual factors are likely to be important in a causal relationship. Our confidence in causal conclusions will be stronger when we know that these factors are taken into account. In a true experiment, the time order is determined by the researcher. The experimental design provides the most powerful design for testing causal hypotheses about the effect of treatment or some other variable whose values can be manipulated by the researchers. It's so powerful for testing causal hypotheses because it allows us to establish 3 criteria for causality with a great deal of confidence. A true experiment in which subjects are assigned randomly to an experimental group that receives a treatment or other manipulation of the independent variable, and a comparison group that does not receive the treatment or receives some other manipulation outcomes are measured in a post-test. The true experiment must have 3 things. The experimental group, which is an experiment, the group of subjects that receives a treatment or experimental manipulation. Control or comparison group. This is a group exposed to a different treatment other than the experimental group or have no treatment at all. And then random assignment. This is a procedure by which each experimental subject is placed in a group randomly. The combination of these features permits us to have much greater confidence in the validity of causal conclusions than is possible in other research designs. Confidence in the validity of the experiment's findings is further enhanced by identification of the causal mechanism and control over the context of an experiment. A prerequisite for meeting each of the 3 criteria to identify causal relations is maintaining control over the conditioned subjects that they're exposed to after they are assigned to the experimental and comparison groups. If these conditions begin to differ, the variation between the experimental and comparison groups will not be what was intended. Even a subsequent difference in the distribution of cases on the dependent variable will not provide clear evidence of the effect of the independent variable. Such unintended variation is often not much of a problem in laboratory experiments since the researcher has almost complete control over the conditions. Real-world settings make it difficult to have control over conditions, though. True experiments meet the criteria necessary for establishing causality in greater detail because they demonstrate the following: an association between the hypothesized independent and dependent variables, time order of effect of one variable on the other, non-spurious relationships between variables, mechanisms that create the causal effect, and then the context in which change occurs. Non-experimental research design can be either cross-sectional or longitudinal. Cross-sectional research design is data that's collected at only one point in time. Longitudinal research design, data is collected that can be ordered in time, also defined as research in which data are collected at two or more points in time. Much of the research you've encountered so far in this text has been cross-sectional. Although each survey or interview takes some time to carry out, if the measures the actions, attitudes, and characteristics of respondents at only one time, it's considered cross-sectional. The name comes from the idea that a snapshot from a cross-section of the population is obtained at one point in time. There are 4 special circumstances in which we can be more confident in drawing conclusions about time order on the basis of cross-sectional data. And this is the independent variables fixed at some point prior to the variation in the dependent variable. We believe that respondents can give us reliable reports of what happened to them or what they thought at some earlier point in time. Our measures are based on records that contain information on cases in earlier periods. And then we know that the value of the treatment, or the value of the dependent variable, was similar for all cases prior to the treatment. So when we look at ADAM and offenders that specialize in different crimes, we look at a research initiative that was done in the US, and this collected data on drug use that for recently arrested individuals when the research was done. It was originally established by the National Institute of Justice to monitor trends in drug use among arrestees, and it was voluntary and anonymous drug testing as well as interviews. And when they collected the data, the arrestees were interviewed within 48 hours of being booked into jail. They provided self-reported drug use histories. A urine sample was collected for drug testing to validate responses. And so the purpose of this was to assess patterns and trends in drug use among individuals that were involved in the criminal justice system. It also helps to provide law enforcement, policymakers, and public health officials with data for developing drug prevention as well as intervention strategies. And they wanted to examine the correlation between drug use and criminal behavior. And so ADAM data helped to identify drug epidemics like meth or opioid use, the surges that we've seen in that. It shows that many arrestees tested positive for multiple substances, which reinforces the link between substance abuse and crime. And it informed the local and national drug policy decisions by highlighting regional drug trends. The ADAM program was discontinued in 2003 due to funding cuts, but was later revived as ADAM-2 in 2007 through 2013, focusing on fewer cities and primarily monitoring cocaine, marijuana, and marijuana use. After 2013, though, the program was permanently discontinued due to budget constraints. And so even though ADAM no longer operates, its methodology and findings remain very influential in shaping drug policy, law enforcement strategies, substance abuse treatment programs. The data collected provided so many valuable insights into how drug use contributes to criminal behavior, which is helping to guide criminal justice reforms as well as public health interventions. Longitudinal designs. In a longitudinal research, data is collected at 2 or more points in time, and for this reason can be ordered in time. By measuring the value of cases on an independent variable and a dependent variable at different times, the researcher can determine whether variation in the independent variable precedes variation in the dependent variable. In some longitudinal designs, the same sample or panel is followed over time. In other designs, sample members are rotated or completely replaced. In a repeated cross-sectional design or trend study, these features make the repeated cross-sectional design appropriate when the goal is determined whether a population has changed over time. This is the repeated cross-sectional design trend study. When we do need to know whether individuals in the population changed, we must turn to a panel design, and that takes us to the fixed sample panel designs. Panel designs allow us to identify changes in individual groups or whatever we're studying. Fixed sample panel design is a type of longitudinal study in which data is collected from the same individuals, the panel, at two or more points in time. In another type of panel design, panel members who leave are replaced with new members, and there's 3 steps involved. A sample, called a panel, is drawn from population at time 1, and data are collected from the sample. As time passes, panel members become unavailable for follow-up and the population changes. At time 2, data is collected from the sample people as at time 1, the panel, except for those who cannot be located. Because a panel design follows the same individuals, it's better than a repeated cross-sectional design for testing causal hypotheses. Expense and attrition can be difficult and very expensive to keep track of individuals over long periods of time. And inevitably, the portion of panel members who can be located for follow-up will decline over time, which refers to the attrition. Subject fatigue is that panel members may grow weary of repeated interviews and drop out of the study, or they may become so used to answering the standard questions in the survey that they start giving stock answers rather than actually thinking about their current feelings or actions. In an event-based design, often called cohort study, the follow-up samples at one or more times were selected from the same cohort, which is people who all have experienced a similar event or a common starting point. An event-based design or cohort study includes the following: birth cohorts, those who share a common period of birth, born in the 40s, 50s, 60s, etc. Seniority cohorts, those who've worked at the same place for 5 years, 10 years, and so on. School cohorts, freshmen, sophomores, juniors, and seniors. An event-based design can be a type of repeated cross-sectional design or a type of panel design. In an event-based repeated cross-sectional design, separate samples are drawn from the same cohort at 2 or more different times. In an event-based panel design, the same individuals from the same cohort are studied at 2 or more different times. How well do the research designs just described satisfy the criteria necessary to determine causality? Although it's relatively easy to establish that an empirical association exists between an independent and a dependent variable in these designs, the other criteria are much more difficult to assess. Recall the issue of spuriousness. To reduce the risk, the technique of the statistical control may be used. A statistical control is a technique used in non-experimental research to reduce the risk of spuriousness. One variable is held constant so that the relationship between 2 or more other variables can be assessed. Blackwell and Picaro found that self-control predicted criminal aspirations for individuals at all levels of income, which is a control variable. So an individual's level of income could not have caused the association between self-control and criminal aspirations. This is an example of statistical control. Our confidence in causal conclusions based on non-experimental research also increases with identification of a causal mechanism. In criminological research, we obtain samples from many different units, including individuals, groups, cities, prison, countries, and so on. We make generalizations from a sample to the population. It's very important to keep in mind the units under study, which are referred to as the unit of analysis. Units of analysis is the level of social life on which a research question is focused, such as individuals. In many research studies, the units of analysis are individuals, but in other instances, the units may be groups instead. So families, schools, prisons, towns, states, countries. We can distinguish the concept of unit of analysis from the units of observation. In most studies, the units of observation and the units of analysis are the same, but not always. Units of observations are cases about which measures actually are obtained in a sample. Note that measures of association tend to be stronger for group level than for individual level because measurement errors at the individual level tend to cancel out at the group level. Researchers should make sure that their causal conclusions reflect the units of analysis in their study. Conclusions about processes at the individual level should be based on individual level data. Conclusions about group level process should be based on data collected about groups. When this rule is violated, we can often be misled about the existence of an association between two variables. There are two errors that can take place when this happens. The ecological fallacy, which is an error in reasoning in which incorrect conclusions about individual level processes are drawn from group level data, or a reductionist fallacy, an error in reasoning that occurs when incorrect conclusions about group level processes are based on individual level data. The fact that errors occur in causal reasoning can be made should not deter you from conducting research with aggregate data, nor should it make you unduly critical of researchers who make inferences about individuals on the basis of aggregate data.